So in the part A of this first question, we are supposed to draw the speed time graph to illustrate the motion of the train as it moved from station A to station B. And the first piece of information is we have the train is at rest at station A, and it accelerates uniformly for t seconds to reach the speed of 20 meters per second. So its initial speed is 0 and its final speed is 20, and it accelerates uniformly, which means it's going to be a straight line, or it should be a much steeper line. Yeah. All right. And yeah, that's how it accelerates to 20. Then it travels at a constant speed of 20 meters per second for 3 minutes. So it travels further for 3 minutes. So for the initial part, it took t seconds, and this will be, okay, so it took 3 minutes, right, to travel at a constant speed of 20 meters per second. So this will be 180 plus t. And finally, it decelerates and comes to the rest at station B. And the magnitude of deceleration is half of the magnitude of acceleration, right? So magnitude of acceleration is actually twice the magnitude of deceleration, which means the slope of the deceleration would be half in magnitude than the acceleration. So we'll draw a less steeper slope. And this would be, so it took t, 180 plus t, and that's finally it comes to at rest, again at 0. And since the magnitude of deceleration is half of the acceleration, so it would take 2t to comes to the rest. So the final time will be 180 plus 3t.